In question number 6, we have a pendulum bob of mass m on a cord of length L. I'm going to go ahead and label cord L here on the sketch in blue. Notice that this is the same length L of the pendulum bob at the lower position. Let's call the upper position A and the lower position B. And we want to know the change in gravitational potential energy. So one of the reflexes you might have is that gravitational potential energy is equal to mgh. And so we want to compare the gravitational potential energy at A to B. If we call the lower position at point B here, we call that reference plane 0, then we can say that the gravitational potential energy here is 0, and the gravitational potential energy at A is not 0. So the change in gravitational potential energy then is just the gravitational potential energy at point A. If I wanted to formalize that, I could say that the change in gravitational potential energy is mgh at A minus mgh at B. But at B, it's 0, and so therefore it's just the mgh at A to find the change. The trick in this problem really isn't seeing that. It's being able to describe this letter h, right, mg times h, in terms of the length of the pendulum. You can see that most of these answers start with mg. And then the question is, how are you going to describe the height in terms of the length and the angle theta? So in this case, I'm going to draw a triangle here in this black color and shade it in. And notice then that really what I'm looking for is this. This is h. That's the height above 0. And this side of the triangle, I'm going to call, let's just call that side y. That's the y dimension of the triangle. I could say that L minus y is equal to h. That's the height. And y can be described in right triangle trigonometry. If this is the angle theta, this top corner here, that's theta, then y is the adjacent side. And I know I'm going to use cosine. We should remember that cosine theta is equal to adjacent over hypotenuse. Or I could write it this way as y over L. Therefore, L times cosine theta is equal to y, which is what I'm looking for. And that's going to get substituted into here. So L minus L cosine theta is equal to h after I make that substitution. Notice that I could factor out the L if I wanted to. That becomes L times 1 minus cosine theta is equal to h. And that's what gets substituted ultimately into h here for h sub a. So it's mgl, then 1 minus cosine theta, which is why a is the correct answer. I think that's a tough problem for first-year physics students, but you will see this expression again. So I would take the time to commit that one to memory.